In this video, we're going to take a look at how to make assemblies in Onshape. If you'd like to use the same document that I'm using here, you can make a copy of it by clicking on the link in the description below. All right, so once you have the file open or your assembly open that you, or your Part Studio open that you want to work with, we're going to move over to the Assembly tab. If you don't have an Assembly tab, you can always click this little plus button and create a new assembly. But since mine is there, I'm going to go ahead and click Assembly 1. All right, once we're in the assembly, you'll see we have no parts in here, so we're going to need to add the parts that we would like to assemble. To do that, we're going to use the Insert button. Right now I'm going to pull files from the current document, which are all located in the Part Studio. If I needed parts that were outside of my Part Studio, we would have to go to Other Documents and then find them in your Onshape files. Okay, so we're going to go ahead and start here with parts numbers 8, 9, and 10. So I'll choose those 3 parts. I'll move over here to the right, and we're going to click to place those onto the assembly, and then check. All right, so a couple things I want to show you before we jump into this. Each of these parts have what we call 6 degrees of freedom, and the 6 degrees of freedom are basically movements or directions or rotational axes that these parts can either move along or rotate around. And so to give you a visual of that, if I click on the part, you can see that this part can move in this direction, it can move in this direction here, and it can also move in this direction here, and that coincides with our X, Y, and Z axes. But they can also rotate around each of those axes. So it can rotate in this direction, it can rotate, I think that's the one I just did, that direction, and then the other one would be this direction right here. And so we've got 6 degrees of freedom that we can move within. Okay, and that's the idea with the assembly. By taking 2 parts and putting them together, in essence what we're doing is we're removing degrees of freedom. And we have a whole bunch of different mates up here. We have a fasten mate, a revolute, a slider, a planar, cylindrical, pin slot, ball, parallel, and tangent mates. And all of those remove certain degrees of freedom. So the first mate that we want to look at is the fasten mate. So I can either click up here on the fasten mate, or I can click the key M on your keyboard, and then you can choose pretty much any mate that you want to work with. So we're going to leave that on fastened, and then we're going to use what we call mate connectors to put these parts together. So I just want to show you how the mate connectors work. So essentially, any plane that you move over, you'll see you have a variety of points that you can select to join together with another part. And so generally speaking, you want to be a little strategic about which one you choose so that you minimize the amount of work that you have to do, or the amount of moving these parts around to get them to their desired point. So for example, if I wanted to say put this little face right here, I want this face to be sitting on top of this face here, you can see that both of these, I can grab a mate connector, or I can grab a point there in the middle of both of them. And so that's pretty convenient for us. So I can say click on that part right there, and then the second one I can click on the middle of that part, and you'll see that the 2 parts are then fastened together. And you can see there is a little gap here, and we will be able to correct that. So we'll move that little piece forward here. But I wanted to show you a few things real quick first. So some of the tools that we can do, the first tool we can is what's called the offset, and so that will help us to fix that gap. Okay, so I can offset this part in the X direction, the Y direction, or Z, and that's going to basically allow us to move it dimensionally one way or another. So I don't want to move this thing up or down, so that would be the Z axis, or in the X direction. So if I just show you what that does, maybe 1 inch in the X direction, you see it moves off, kind of off to the back of the part. Okay, if I did a -1, you'll see it goes the other direction. So you can simply put in whatever dimension you want using positive or negative to move it, in one direction or the other. I'm just going to move it a 1/4 inch in the Y direction, and that's going to close that gap. But some other things that you need to see, and that works out pretty well for that one there. I can also rotate. So maybe I wanted to say rotate around the Z axis by a certain degree. So I could go like 15 degrees, and you'll see that it rotates it. And so that works out pretty well. I'm going to leave that at 0. The other thing that you can do is you'll see if for some reason you put the 2 pieces together and they went like this, so the faces are still together and they're still offset, but they're just like one's on the wrong side, you can simply flip the primary axis. And the other thing that you can do is reorient the axis by simply clicking this, and that just moves it 90 degrees at a time around the secondary axis, which in this case would be the x-axis there. So I just want to get it in the right orientation. You just kind of move it around until you get it where you want to go. So I need to flip that, reorient. There we go. I got it in the right spot. All right, so we'll go ahead and so the fasten mate simply removes all 6 degrees of freedom once these are put together and you've got it either offset or rotate it how you want. We'll hit check, and then now you'll see if I move these parts, they move together, right? They are locked in place together. So the fasten mate is going to be for something that you just want these two parts in a certain spot. You don't want them to move after that, and then you can move forward with your setup there. So the next thing that we're going to do is add the second one in. So I'm going to go ahead and just simply put this face right here. I'm going to connect that face to this face right here and set that up. So again, I'm going to click M on the keyboard. It's asking me to choose the mate connectors I want to use. So I will take this one right here, right in the center, and we'll take this one here, right in the center. Click. So you didn't grab it. There we go. And those two are connected. I don't need to do any kind of offset or anything like that because the faces were connected directly. All right, so the next mate that we're going to look at is the revolute. So to do this one, we're going to need a couple new parts in the assembly here. So we're going to go insert part number 1 and part number 2, put those in the assembly, and hit check. All right, so now first thing I'm going to do in order to be able to see this one work the way it's supposed to, I'm going to right click on the cube and I'm going to fix this one in place. So basically what I did is now I can't move this part around. It's kind of anchored in the current spot, so I can't move it. And what I want to do, so you can see I can still move the little key around here, but what I want to do is I want to be able to put the key into the hole here, and then, but I want it to be able to spin. Okay, so in doing so, the revolute will allow us to do that. So the revolute will take whatever points that you want to mate together. It will lock those points together, but it allows the rotation around a particular axis. So again, we're going to click M on the keyboard. We're going to choose, this time we're going to switch it to a revolute, and then we're going to choose the mate connectors that we want to work with. So I will kind of rotate this around, zoom in. I'm going to grab the end of the cylinder there, and then come back to the front here, and then I'm going to choose this little front mate connector of the hole. And you can see here, if I hold shift, okay, I've got this little cylinder highlighted, and I hold shift, I can go back and choose these other ones as well. So if I wanted the end of the key to go up to this point, I would choose that one. If I wanted the end of the key to go all the way through, we could do that, and then you know, that would be fine. But we also have the ability to use the offset again to be able to say, you know, put it in a certain distance. So all right, so we'll go ahead here and just choose this front one, okay, and then this. So grab that. There we go. All right, and then now I'm just going to go ahead and hit just to show you what would happen if we flip the primary axis. Okay, if we flip the primary axis, you'll see it's all the way through the block now, but going the other direction. So I'll flip that back just to show you what those do. And then now we're going to say offset this just a little bit. So I'm going to go maybe like 0.5, hit enter. So it's not quite to the middle, but it's a little bit. And then we're good to go there. So I'm going to hit check. All right, and now the next thing I'll show you here is this. So like we've got the block that's fixed, and we've got the revolute put on. So now I can grab this, and you'll see that it allows rotation in this direction, but it does not allow me to move this left and right. So this is a great tool if you want to do anything that's kind of like on a hinge or that needs that rotation, but doesn't allow the part to say move along the axis as well. So just rotation about the axis. So another neat little thing you can do here is we're going to go over here. Any of the fastens or any of the mates that we use, we're going to show up here. So if I go to the revolute and I right click on that, you can animate. And if I hit play, you'll see that it's going to show that rotation. Right now I've got it on reciprocate, so it'll go 1 revolution from 0 to 360, and then it's going to go back the other direction, back to 0. So you'll see it switches the other way. You can add more rotations to that. You can increase the speed by lowering the number of steps. So I'll hit play there, and you'll see it'll go a lot faster. You can do a reciprocate, you can do a single, or you can do loop, and it'll just continuously run in one direction. So little things you can play with there. So that's great. You can animate once you learn to start connecting a lot of these together. You'll be able to run full animations on quite a bit of stuff. It's kind of cool. All right, so moving forward, we're going to go to the next one. We're going to do the slider. And so the slider, we're going to take parts 3, 4, and 5. We're going to move those out here. Okay, we're going to set those in and hit check. All right, so the point of the slider, before I do that, I'm going to go over here and just hide this little thing. Right click, hide all mate connectors. There we go. All right, what I'm going to do is I'm going to take this block, put it in this groove, and it should be able to slide back and forth in the groove. So to do that, we're going to click M. We're going to change this to a slider mate. And essentially what I have to do is lock 2 axes together. Okay, so whatever points I use, I want those to kind of match up. So you can kind of tell here that you can see if I hover over this plane, we've got this point down here. And if I hover over this one, it seems to match up with this point here. Okay, so that works out pretty easily for both of those, but we could still use offsets if we needed to. So what I'm going to do is hover over this plane. And one thing that's going to be very helpful for you is to hold, so once we hover over the plane, or the face, we're going to hit shift and we're going to hold that. And what that does is, regardless of where I move my mouse, it locks all the mate connectors on that particular plane. So, and the reason that's important is because if you see, the blue axis, the z-axis, is kind of pointing like perpendicular to that face. And so that's what I want. That is going to be the direction of the sliding. So it's going to be along that z-axis. So I'm going to choose this mate connector. Okay, and I'm going to go over, I'm going to hold shift, I'm over this face, I'm going to hold shift, and then I'm going to choose this one here, and you'll see that they are now connected together. So I'll go ahead and hit check, and then we can try this out. So if I grab the block now, everything kind of moves. It does slide a little bit, but let's go ahead just to make it easier, and let's fix this little gray block in place. So right click, fix, and now this thing can't move, but the slider can certainly move through the block, which is great. That's what we want to see. All right, so now we're going to add some stuff to this. So actually, before we do that, you can also use the animate tool on this. So right click on the slider, mate, animate. I'm going to set it from 0 to say 6 inches, and let's set these steps a little faster. So 100, and then hit play. And you'll see that it starts at 0, which is the face that we selected. So that's 0, and then it will slide 6 inches, which is to the end of the gray block. So that's perfect. You can kind of see it working. Works out great. So what I want to do now is we want to make some edits to this, and we're going to put the peg in the hole, and then I want this slider to stop when it hits the peg. Okay, so we're going to use the mate tool. We're going to make that a fastened, and I'm going to choose, say, the end of this and the end of the circle. Okay, we're going to put that there. If for some reason yours is sticking out like that, not a big deal. Just flip the primary axis. All right, so we've got that fastened. I don't need another fasten, so we'll hit X there. But when I run this, you'll see it goes right through it without stopping. Okay, so what I want to do is I want to put some limits on this. So I'm going to go back to the slider mate that we put in. I'm going to double click on that to make some edits. So I don't need to do any offsets, but we do need to do a limit. So this one says no minimum. So if I put a minimum, this face here that we chose for the mate connectors, that's 0. So minimums would be negative. So if I want to come out of the block, that's going to be negative. And anything to the right, or kind of towards the back of the screen there, is going to be positive. So if I said maybe I wanted to limit it to -3 inches, and then the maximum needed to be 5 inches, you'll see what we can do. So it'll come out 3 inches. That's as far as it goes, so it won't let me go any farther than that. And if I go this way, it stops at 5 inches, which happens to be the location at which the cylinder is set up. So even though it's not really recognizing that there's another part there, we've got it kind of like set up through measurements, limits through measurements. So it can't go any farther than that, and it'll stop at the right spot. So it's another handy little tool that you can use with assemblies. All right, moving forward. The next parts that we're going to take a look at are parts 6 and 7. So we'll just place those out here. And once we place those out here, we'll hit the green check. And then we're basically going to take like what looks like this air hockey puck, and we're going to put it on this surface, and we're going to make sure that it can move freely on the surface, but that it can't leave the surface. We're going to do that using the planar mate. So again, we're going to click M on the keyboard. We're going to change this to planar mate, and I'm going to choose, and since it's on the plane, it doesn't really matter which one of these you choose, but since it's easy to grab the middle, choose that. And then I'm going to choose the bottom of the paddle, and you'll see that those two kind of lock together there. And we'll go ahead and hit check. All right, so what this is going to do now, let's go ahead and fix the surface in place. So fix, and if I grab the puck, you'll see that it'll move all over this thing, but I can't lift it up and down. It's always going to stay on that plane. So if I try to move it up and down, it looks like it did, but it actually just kind of left the surface. It's always on the plane set up there. So if we wanted to say place some limits on this so that maybe it couldn't go off of the edges, then again we can go and place those limits. So I'll go to the planar mate, double click on that. We will add some limits, and I don't really need to add limits in the Z direction because that's the blue that's up and down, but I will need to put some limits in the X and Y directions. So for the minimum, I'll put say -2. For the maximum, we'll put 2, and same thing for the Y direction, -2 and again, this is all from the center. So we'll leave those in there, hit enter, and check. Okay, so now if I grab this and say, you'll see it only moves a total of 4 inches. It can go anywhere in there, but if I hit a limit, it stops. So that is the planar mate. All right, moving along, we're going to go in and we're going to grab a few new parts here. This time we're going to grab 11 and 12. So put those here and check. And this one's going to be pretty simple to use. We're going to use what's called the ball mate. So we're going to hit M. We're going to change this to the ball mate. And again, I don't really have to worry too much about my axes on this one because we're just kind of locking 2 center points together. So I just want this little ball here. Click that. And then I'm going to get the socket right here. And we're going to hit check. And now we'll fix this base in so we can see it move without dragging it all over the screen. So now you can see that, let me fix that. So you can see I've moved this around, and it kind of works like your shoulder joint or your hip joint. Okay, it's just a ball and socket, so it kind of move in all these, pretty much any direction. So that's a neat little assembly joint there that you can use. Next one we're going to look at is what we call the parallel joint. So I'm going to grab 13, 14, and 15. We're going to bring those out, and we're going to use some familiar ones that we've used earlier. So M, basically what I want is I want this arm to be on this side of the box. So I'm going to grab that mate connector there, okay? And I want the arm to actually go, I don't want this to have to offset it. So I can choose this mate connector, but if I choose this one down here, I'll click that, and now you can see it goes all the way up to the box, which is how I want it. And we'll hit check. Okay, we can fix the box in place here, so let me close that, right click, fix the box in place, and now you'll see that this rotates like it's supposed to. All right, we're going to do another revolute, so M on the keyboard, revolute. We're going to choose, again, this side of the cylinder, and then we're going to place that here, check, and you can see that this moves to, as well. So the real goal here is I want both of these arms to move together, okay? So they should be going at the same time and in the same direction all together. So to do that, we're going to use the parallel mate. So again, I'm going to go M. I'm going to change this to parallel, which should be the very bottom one, and we're going to kind of link these two together. So if I link this, I'm going to choose, I want this face, so I'll hover over the face, hold the shift key, and I'm going to choose, say, this top middle one, okay? And then over here, we'll do the same thing, hover over the face, hold shift, top middle one. Wait, I think I grabbed the wrong one there. So I'll take that off, and then I want the top middle one there. Okay. I'm gonna have to start that one over, sorry. Okay, so we're gonna go M, we're gonna go parallel, and then I'll just try and use the middle one this time. That one. There we go. And then I'll use the middle one here. There we go. And you'll see what happens is it just drug this one over there. And essentially what it's doing is it's not really worried about the revolutes that we put in. It's worried about the parallel, saying, can I make those two things parallel? And you can see that they are. Okay, but if you want to check all of it together, you can hit this little solve button and it'll check it and say, yep, we can make those parallel and we can use the revolutes. Okay, so I'm going to go ahead and hit check, and then you'll see if I grab one and move it, they both move. Now, since revolute 2 and 3 are the arms there, either one of these, since they're constrained together, if I animate one, you'll see that they both run together because they have to be parallel. They're constrained to be parallel. So now we can operate 2 revolutes at the same time by running those two together. Okay, and then the next one and the last one that we're going to do on the video here is similar. We're going to use these gears, so I'm going to take the 36 tooth, the 60 tooth gear, so I want those, and then we're going to go all the way to the bottom and take also part 17. I'm going to bring those 3 items out. We'll set that there. Okay, and then check. So what I'm going to do now is I want to put this gear and this gear in these holes. Okay, so we're going to use revolutes for that. So we're going to go ahead and click M on the keyboard. We're going to change this to a revolute. And then it doesn't really matter which gear we're going to start with here, but let's say I choose this one. So this gear actually has a square hole, so I can either hover over the surface, hold shift, and then get the middle, or you can just hover out here and get this little circle, and you'll see that the center of the circle is what highlights there. But as long as you get the center of that, either way it works. So I'm just going to grab the circle with the z-axis pointing out, and then I'm going to go down here. I'm going to put that one, say, right there. Okay, and now you can see the gear is inside. So this is a case where I'm going to need to flip the axis. So flip the axis, and there it is. So we'll leave that alone. I can fix this block in place. Okay, and then I should be able to grab that. So let me close this here. Should be able to, looks like it didn't fix. So I should be able to grab this gear and spin that around, so it's working. And now we're going to do the same thing with the other one. So M on the keyboard, change this to a revolute, grab the other gear, do the same thing. I'll probably just grab this outside edge here, click that. And we're going to grab this edge here. Really does not want to grab that. There we go. And flip the axis, and these two gears are together. Okay, so so right now I've got these two that are working, or they're together, they're next to each other, but you can see that one will spin without the other. And so just like before, I could go and I could say right click, animate, revolute 5, and you'll see that only one of the gears runs, but it doesn't necessarily affect the other gear. Okay, so we're going to make it so that when one gear runs, it runs the other one as well. Then we're going to do that through what we call a gear relation. So in the gear relation, and it just your numbers may, like your order may change a little bit depending on which one you did first and whatnot. But if I drive this one, okay, revolute 4 is the one on the left there. Okay, if I drive this one and it's going to turn this one, then the gear ratio is going to be out over in. Okay, so the mates, it wants to know this time not the parts, but what mates do we want to connect together. Well, that's going to be revolute 4, and then it's going to be revolute 5. So those two mates, when we drive one, it's going to drive the other. And then we've got this relation ratio, and that's our gear ratio. So if this is a 36-tooth gear, it's going to be 36 divided by 60. So it's the number of teeth out over the number of teeth in. We'll hit check. And then we'll go here to 4 or 5, right click, and animate. Okay, and again, since they're connected together, you can see that they're running, but it looks like I chose the wrong order. So this one's obviously going a little bit too fast, this one's going too slow. So all I have to do to fix that is just go back to the gear ratio, and you can see that I put in 36 over 60, so it should be 60 divided by 36. We'll do check, and now when I run the revolute, they should run correctly. So looks like the teeth are off a little bit. I can move that around, but they're connected together and they're running correctly. Okay, so if we wanted to add more gears on here, it's not hard to do. You just got to get the correct spacing, and then so like these two are connected together. So if I added another gear, it would be connected to the revolute on this gear, and then the next gear would be connected to the revolute on this gear, and so on and so forth. So, all right, so that's all we're going to cover tonight in the assembly video. Give it a like if you enjoyed this or if it was helpful, and good luck.